Hello everyone! Thanks for tuning in to another episode of Doodling Through Education. It is week 21 for my CC students, and we have a science episode for you today. We are going to be talking about the third law of thermodynamics. So remember, in the previous 2 weeks, we talked about the first law of thermodynamics, the second law of thermodynamics. Now we're going to continue on with that thought and touch on the third law of thermodynamics. So remember, if you haven't already, to subscribe to this channel so you never miss an episode from Doodling Through Education. Let's go ahead and start doodling. The third law of thermodynamics. What does this law state? This law states that it is impossible to reach the state of absolute zero temperature. Absolute zero temperature is 0 Kelvin, or negative 459.67 degrees Fahrenheit. But we can never reach this. In fact, scientists used lasers to cool individual atoms to half a Kelvin, but surprisingly, even they can't reach absolute zero. This is because as the temperature of a system approaches absolute zero, its entropy becomes constant. So remember, in the last science video, we talked some about entropy when we talked about the second law of thermodynamics. If you need a refresher on this, go ahead and watch that video again. So as the temperature of a system approaches absolute zero, its entropy becomes constant. So this means that the change in entropy or disorder is zero. It is impossible to reach absolute zero because molecules will always move. And like we said before in the second law, heat will always move from a hotter place to a cooler place. So no matter how hard they try, scientists can't keep heat from molecules. So why do we even have this crazy, impossible law? This law helps us understand the ability of atoms to be random. This law helps us understand that motion, heat, and order are related. The more molecules move around, the more heat they create, and the more entropy or disorder they have. The more you study heat and energy and work, the more these laws help us understand what is happening in the universe. The third law is rarely applicable to our day-to-day lives and only governs what happens to objects at the lowest of temperatures. It defines what would be called a perfect crystal. This is a crystal whose atoms are essentially glued in their positions. They do not move. The perfect crystal thus possesses absolutely no entropy or no disorder, which is only achievable at the absolute zero temperature. A crystal that is not perfectly arranged would have some disorder or entropy in its structure. And because entropy can also be described as thermal energy or heat energy, this means it would have some energy in the form of heat, so it is not absolute zero. It is important to note that perfect crystals do not exist in nature. This is not something you would find in your backyard or even in Antarctica. And that is all we have for today for this science episode. Understanding the third law of thermodynamics is essential in understanding how heat, energy, and entropy all work together. It gives us a baseline to understand the other laws of thermodynamics as well. And on that note, remember to be kind, follow God's will, and take care. Bye.